All right, guys, so right now we're going to talk about solids, liquids, and gases. I know my camera there doesn't look very good, but whatever. We got to work with what we've got, right? So here I have a glass cup. It's a solid. So solids have fixed um, shape and fixed volume, okay, which means their shape doesn't change very easily, and the amount of space they occupy also doesn't change very easily. Now here, I have a cup with some water. Okay, water is a liquid, and water has fixed volume. The amount of space it occupies doesn't change very easily, but it does not have a fixed or a definite shape. It has an indefinite shape. So when I pour that water into this cup, which you can't see because I just put this down, but anyways, I poured that water into this cup. It's now a different shape. That amount of liquid took the shape from this cup to the shape of that cup. So liquids do not have definite shape. Now here I have Lysol spray, okay? Or something like that. Yeah, there you go, disinfectant spray. And I know it's not all gas, but just entertain me, okay? So gas in here is compressed. It has the shape of this container and the volume of this container. If I spray this, and I can already smell it, okay? It spreads out and it ends up taking the shape of this room and the volume of this room. So gases have indefinite shape and indefinite volume. Okay, gases can be compressed, unlike solids and liquids, and they can spread out. Okay, gases also and liquids are called fluids because they can flow. Okay, so a fluid is something that can flow. Liquids and gases are both fluids. So now what we have here is an online simulation that's going to show us pretty much solids and liquids and gases, but at the atomic level. Okay, so typically when I look at a glass or a solid, if I look at this glass, it doesn't look like it's moving, okay? But actually it is. So if you look at the atomic level here of any solid, there's vibration. Those particles are in position. They can't flow like liquids and solids, but they are vibrating. They have kinetic energy, which is the energy of movement. If I heat this baby up, okay, you can see that I'm getting more and more kinetic energy. And that's when we get a change in state of matter. Okay, now we went here kind of some straight gas particles, and then we got some liquid particles. I'm going to change this whole thing to liquid. Now, as you see a liquid, it spreads out at the bottom, right? And these particles, they can flow past each other. So that's why liquid is a fluid. They've got more kinetic energy. They're not as tightly packed. And some particles sometimes can actually escape the liquid and evaporate and go into the gas phase. Now, if I take and turn everything into a gas, you see that the gas takes up the entire volume and shape of the container, and it has the most kinetic energy of any of the states of matter. Okay, so it's spread out, it's bouncing all over the place. Liquids tend to spread at the bottom. They're more disorganized than the solids, but not as disorganized as the gases. They can flow past each other. And then the solids are pretty tightly packed together in position. But if you were to zoom in at the atomic level, you could see that those particles are actually vibrating in place. So that's what we got there for solids, liquids, and gases.